Hey 211, I just wanted to make a quick video since we didn't get to have a last lecture together that offers you some future directions on some ideas that I think would be interesting to take given what we learned together in class. Before I get into it, I just want to say that you all did a fantastic job this semester making it through our pilot course. We appreciated all of the hard work that went into it, and you all crushed it by and large this semester. So great work on a very difficult subject matter this semester. So I've got 5 ideas of things that I think would be interesting for you to check out this summer. Before I get into it, I also want to point out very shamelessly that I'm going to be recording YouTube videos all summer long. So if you want to hit that subscribe button and help me pursue my dream of becoming a shameless YouTuber, that'd be great. So the first thing that I think would be interesting to learn is a new language called Rust, or I should say a new-ish language called Rust. It's been around for about 10 years now. And Rust is a new modern systems programming language. So just like C is a systems programming language, and one of the key distinctions of a systems programming language is that you can get access to addresses in memory and work at the address level and have some direct access to memory in a way that you don't really have access to in languages like Java or TypeScript or Python. And so Rust is a system programming language that attempts to make amends with all of the sharp edges and to smooth out all of the sharp edges of the C programming language. So many of the ways in which we intentionally taught you C this semester, we taught so because it would help prepare you to learn a language like Rust. So we used words like lifetimes. How long is it that a variable is around either on the stack or the heap or in static memory for? In C, enforcing the rules of lifetimes, especially for dynamic memory, is on you as the programmer, right? Like we had to remember to explicitly free our memory and to be careful not to use it after we freed it, or not to return an address to some lifetime that had been expired. All of those things, the Rust programming language checks automatically for you, and your program won't even compile if you break one of those rules. And it does so by introducing some new syntax that you'll never see in any other current programming language that I'm aware of. It's some syntax for saying, hey, here's the actual lifetime of a given variable or a given reference that we're using in our program. And it has some additional compiler capabilities that allow it to check and be sure that you're using addresses in memory in a safe way. It's a very much more modern feeling language. It has type inference. So if you declare a variable, you don't have to say that and you initialize it to say a value like 5, it will automatically infer what data type you're talking about with some heuristics. And it has generic types, so like what we had to do with vec in like having to really bend over backwards to write a generic vec implementation that allowed us to have a vector of any type. Rust has generics just like Java and TypeScript that make that a much more pleasant process. Rust also has a built-in library for things like vec. In fact, our vec implementation that you did comes from Rust, and we followed the Rust implementation. So if you read the documentation on Rust for vec and stir, you'll see that we actually followed in their footsteps here and implemented in C what is built into the standard library in Rust. So this is notoriously a difficult language to learn, but I actually think right now is the best time in your career to learn this language and to experiment with it because of how we taught 211. In the future, I would really love to be able to fit a week or two of Rust into the end of the course if possible, but we would have to give up something else. I'm not sure what that would be yet, but I do think you are in a very good place to learn this new language that's becoming a big deal in systems programming. The second thing I would encourage you to do is look at advanced Git. So Git is a technology that we explored the most important fundamentals of, but it actually goes much deeper than what we did in class, right? And so with Git, there are more things that you can do, especially when you're collaborating with others. And so I've gone ahead and put up in our Sakai site an etc. folder. So in our resources, if you go to etc., you'll see that there are some slides on remotes and tagging. And there will also be some videos that are posted with the announcement for how to pull and push code to remote repositories and work in a collaborative way. The other thing I would encourage you to do is get a better handle on what it is that GitHub offers and to explore things like issues in GitHub and pull requests. So pull requests are how you make a branch on some project And if you want someone else to approve merging that branch in with a project, you'll create a pull request. This allows you to have a threaded discussion around what it is and manage this process. Most open source projects use pull requests, so if you wanted to contribute to an open source project this summer, I would encourage you to try, no harm in doing so. Create a pull request on some little bug fix that you've made and get some experience with this process, because this is how many people and teams in industry work on projects. There's one other sort of stretch goal I would give to you this summer with respect to Git, and that is looking at GitHub Actions. So this allows you to automate certain actions to take place when you push your code up to a repository. So in the way that we pushed our code and then submitted it to Gradescope, with GitHub Actions, what you're doing is setting up some scripts that are running in Docker containers on the GitHub side that will automatically run as soon as you push your code. And so you can automatically deploy a project to the web, build things, test things. This is really a new functionality that's come out in the last year that's really powerful. The third thing I would encourage you to do is make a personal website. There are two resources I'm going to encourage you to check out here. The first is HTML and CSS is Hard at the web address internetingishard.com. This is one of the best free online books I've found for HTML and CSS that feels modern and up to date with where we are at in the world in 2020. This is a required reading for students who take COMP211 with me, and it's really, really good. And so if you want to get started on some web development and make your own personal website, this is where I would begin learning what is going on actually in HTML and CSS. And then once you have started to build your website, you make that into a Git repository, and you can set up either GitHub Pages, and that allows you to host a website on GitHub through static HTML and CSS, or a web service called Netlify, which is also Git based. So it's going to be one where you push your code and Netlify deploys your personal website for you. Both of these work in very similar ways, and I think it would be fun to experiment with both if you want to set up a personal website to start tracking your project and the things that you're doing throughout your courses and on your personal time. The fourth technology I would encourage you to check out is one that we used all semester but really didn't get to talk about head on, and that is Docker. So Docker is a platform for working with containers, and containers is sort of an overloaded term that means many things, but effectively it means you're able to run a process in a protected environment in such a way that you're guaranteed that the applications in the file system are set up in a way that you can expect will be true each time. And so we made use of this in our course by having a developer environment that you ran. Every time you ran Learn CLI, the Learn CLI script to begin a session, you were beginning a Docker container process that was our bash shell. And then from there you could start other programs, but each of us then was guaranteed to have the same starting file system, except for what we mounted in. But that's what allowed us to delete files and not really have to worry about it at the system level. And this is becoming, containers have become a important technology that people like Google and Facebook use to manage not only their production services, but also to set up developer environments. All along those lines, I've also posted a slide deck that we didn't get to on an introduction to Docker that's aimed specifically at where you would be in this course and talks about some of the things that you might do given the context of what we've done so far. And I think that would be a good starting point if you're interested in learning about Docker. The last thing I would encourage you to do is to read a site called Hacker News, and this is news.ycombinator.com. And this is a site that kind of works like Reddit, where people submit stories and then people vote on them. So the first page has highly voted stories or stories that are on the rise. And just scan the headlines each morning and see what are the things that people in the software engineering and the startup and the technology community are really thinking about. This is a website that I've read daily for the past 10 plus years, and it continues to be my favorite resource for learning about what's new and exciting or just interesting and fascinating in the world of tech and some of the related areas that people are concerned about. It's a great resource. I would highly encourage you to read it daily, and you'll learn quite a bit about the greater environment that we're working in as software engineers. These are the 5 things I would encourage you to check out this summer. In addition to that, trying to expand on the shell that you built for this class I think would be really fascinating. Doing things like adding file redirections would be very cool. And other things like tab completions might be fun and a really big challenge using a library called ncurses. In other ways that you might expand on the shell by introducing things like shell variables or if then else statements. There are many directions you could take to make our simple little shell a more complete shell. But that's about it. So I just wanted to say thank you for all of the work you put in this semester. You all will be in great shape going into COMP211 in the fall, and I hope you have a great summer and get a little bit of relaxation in. But if you want some extra ideas, hopefully this is helpful.